All right, so this video is going to serve the purpose of just kind of showing you what Fusion CAM is capable of on the mill. So after this video, this is when we're going to start getting into how do you get the finer details. How do you actually write code, all that good stuff. But this video is just kind of an overview of what you need to know as far as what the software is capable of. All right, so pretty much everybody has had the class where you're using this design tab here in Fusion. All right, so this is where we actually draw the parts. All right, now this part here, this was just the one that I've been working on recently. This is the center mass version 5. But I'm just going to kind of open this up and show you how I drew this. All right, now with CAD and CAM and all this software, there's always a million different ways to do stuff, but this is just the way I do it. Now, anybody that has had a CAD class from me knows that I like to draw things that will be editable later. All right, so very few things do you ever get the design just right in the very beginning. All right, so what I do is I try to make it adaptable so that the model doesn't explode when you try to make a change to it. So what I did on this part is I drew half of it, and you see where I drew that line right there, and I wrote the radius. See that 250 and a half right there? So if I finish this sketch, you'll see what I did. Let me turn that sketch on so that you can see. So that's the way I drew it, and then I did a revolve. Okay. Did a revolve to shoot that around. Now, this is very easy to change because, let's say that I needed to get in here and we decided that, the diameter here was too big. We could just change this really easily and be done. Right, and no, this is the good thing about having software that is both CAD and CAM. Right, so when you look back a handful of years ago, the standard was you had a CAD software and then you had a CAM software. And what you did is you drew the software, or I'm sorry, you drew the model and then you imported that into software. Now, that was great if you didn't need to make any changes. But if you needed to make changes, you pretty much had to start from scratch. And what I mean by that is I'm going to go right over here to manufacture, and we're just going to look at op 1. All right, and I'm just going to run this on graphics. We're going to talk about all this, but I just want to show you. So, see, this is showing coming in, drilling holes, all that happy stuff. Okay? Now, back in certain software years and years ago, and some software is still this way, but if you needed to make a change, like let's say that the print changed and this diameter was different, you would have to go back and start completely over, rewriting all this code. All right, and it was a big pain, as you can imagine. So right now, I'm just going to come in here and make a change. I'm just going to edit this sketch, and I'm going to change this to 0.375. I'm going to change this to a 1/2 inch. Okay, and then we're going to finish that sketch. All right, so the model has changed. I'll come over here to manufacture. See, all this stuff is red. All I have to do now is regenerate that code. And we're good. We're done. All right, the new update is fixed. And there it is. That's my simulation for my new updated Rev 2 model. Okay. Now, before I forget about it and screw everything up, let me go back here and change this back. Hope I get it right. And I think that was it. All right. So the good thing about this software, about having both CAD and CAM under the same umbrella, is you can make all these changes on the fly and it doesn't hurt you. All right. Well, I'm not going to say it doesn't hurt you. It doesn't cost you a ton of time. It costs you a little bit of time, but not terrible. So I'm going to come back over here to manufacture and, change the model. So I have to come in here and obviously update it. All right, so I'm going to go right here, generate again. And now we're back to our old original model before I made those changes. Okay, so in this software, you're going to have different ops. All right, you're going to have op 1, op 2, whatever. And it's really important that before you pick what is going to be op 1, what's going to be op 2, you really need to think about work holding. All right, so our material for this project is 3.5 inches in diameter. And I'm going to check this. You see my diameter of my model is 3.375. That means that we have a 1/16 inch on each side that we're going to be able to cut off, an 1/8 inch total. And then my stock thickness, I looked down there in the bin and it looked like they were kind of, it was a couple of different differences in material. But I'm just clicking I for inspect to check this. My part is 1 inch thick. All right. So with when you've got different material, so when I said I checked a couple different lengths and they were all over the place. One of them I picked up was 1.5 inches. The other one was 1 5/8 inches. All right. So what I'm going to do is I'm going to go to worst case scenario there. All right. I'm going to go to 1 5/8 inches, meaning that I had an 1/8 inch of more material to cut off. All right. And this is because I don't know what piece of material each student's going to pick up. All right. So what I've got here, if you look at this op, and when I say this op, when you look at this setup, if I click this, this is where everything begins. All right. This is where you tell it whether you're milling, turning, additive, whatever. All right. Obviously we're milling. All right. This is where you tell it the orientation, like where do you want your G54 set? So for a rotative type part like this, it makes all the sense in the world to do G54 in the center. All right, that's where everything's based off of anyway, so it just makes sense. All right, so this is where we select all that. Like if I wanted to put it, like let's say that I wanted to put the, let's see here. Give me 1 second. Let's say that I wanted to put the origin here for some reason. All right, that's where you could select it. Let's say I wanted to put it there, whatever. Come on. But it makes sense right here. Okay, this is where you select which way you want your X positive, Y positive, all that stuff is where you pick all that. All right, and the way it's sitting right now with my Z going up, my Y going back, my X going to the right, if I was standing in front of the machine, this is the way that part would be sitting. I want you to notice that I've got a hole at 3 o'clock and 9 o'clock. I do not have a hole at 12 o'clock or 6 o'clock. That's going to come into play here in a little bit. All right. So then you come over here, you pick your stock. You say, how big is your stock? All right. So if you notice, I put in 3.55, but I told you that the material was 3.5. This is just me giving myself, well, giving the students, myself, whatever, a little bit of wiggle room to where if their offset is tweaked a little bit, you know, let's say they forget to put in a tool diameter or something like that, this will give us a little bit of cushion. And plus the material may come in 20 thousandths big, 30 thousandths big. This gives us a little bit of cushion. All right. And then I told it that I've got 1 5/8 long material, offset from the front, and I'm telling it that I've only got, you know, whatever 10 thousandths. So see right there where the stock comes up. Let's carry it to extremes and set that to 0.5. Like let's say we had a 1/2 inch extra material. All right, we don't have that, so we're just going to put 10. Okay. All right. Now, one of the things that I want to mention is this is the mistake that a lot of people make, and this, again, this is an overview video. You know, we're not doing any real instruction here. It's just an overview, but I do want to cover this. If you notice, that origin is on the stock. That's not at all what we want. We want the origin to be on the model. So I'm going to go model box point. You see that? So now, if I come back over here and I change this to a 1/2 inch, my origin is on my part, not my stock. Okay? And the more you machine, the more that's going to make sense to you. Is you never really want to set offsets off of stock whenever possible. You want to set them off of your part. All right, and right here in this next tab, so you got 3 tabs here. You got your setup. That's where you do your origin, all that good stuff. Your stock, obviously that's where you enter your stock information, and then your post-process. This is where you enter in whatever you want your program name to be, whatever you want your comment, all that good stuff. And then once you finish that, you're good. Now, once you have your setup, all right, once you have the setup done, you know, you got your origin picked, you got your stock picked, you got all that good stuff picked, that's when you can go in and start adding in your strategies. Okay. Let me generate this one more time. I changed the stock so it made all those not valid anymore. Okay. So the first thing I'm doing is I'm coming in facing it. And all I did was right-clicked right here, new operation, 2D milling, face. Okay, now again, we're going to get into all this stuff. We're going to be talking about all these different strategies. We're going to be talking about drilling, 2D milling, 3D milling. We won't get into multi-axis. Mac 128 covers turning, and we won't be doing any of the straight-up cutting. Okay, but really, we're going to spend a lot of time on these, and we'll do a little bit on these. We're not going to get real crazy into 3D, but if you get a good fundamental understanding of these and the 2D milling and drilling, then you'll be able to do the bulk of CAD/CAM work out there. Okay? Now, I've got my face. I've got this listed as trachoidal, and what that is doing is I'm going to click on that, make it stay active. I think so anyway. Yep. So what that's doing is it's helixing down into the part, and then it's going to take circular bites. All right, the blue lines here are cut lines, and the yellow lines are high feed lines, meaning that it's not going to wrap it. It's going to do, like, just instead of going to a GO, it's going to go a G1, like 750 inches a minute. It's just it makes it position a little bit faster. Okay. Now, we're roughing out that slot there. Then we're going to rough the OD. Spot drill all those holes. Spot drill that center hole. And I did those in 2 different strategies because I'm going to different depths. Okay, see that goes to a certain depth. This one goes to a certain depth. All right, then we're going to pre-drill all the way through and then some. Ream, pre-drill. Now, if you notice, I skipped 2 holes here. So I skipped this hole and this hole in this strategy. Now, in the very beginning of this video, I told you that you need to make sure that you are that you have a good understanding of how you're going to machine this part before you start writing code. You know, you don't want to just jump in here and start throwing strategies and tool paths to it. You need to have a good, solid understanding of how you're going to hold it, how you're going to pick up offsets from op to op, and all that. So you need to have a good, solid understanding of that. So the reason these are different is because I didn't want to drill all the way through with these holes, but I did with these. All right, so look right here. So look at the different depths. And that's for a specific reason. So like when I ream, see I ream all the way through the part, but here I ream all the way through the stock. So let me just show you like that. All right, you see, come on. So you see my stock there, not going all the way through, going all the way through. Now, the reason for that is when we flip this baby over, when we put this thing on op 2, let's see here, flip that baby around. All right, obviously we're going to be able to pick up our part origin off of this hole. We'll be able to use a coax indicator and we'll be able to sweep this in really, really close. All right, but another issue that we're going to have is clocking. So if you were to just put this part in here like that and it was off angle, then when we deburr these holes, it's not going to be correct. All right, those holes need to be in a correct location. So you need to be able to clock this correctly. And the plan for this is, being that we've got these 2 holes that are all the way through, you'll be able to put dowel pins in this hole and this hole, and you'll be able to put a parallel across. And tell you what, let me show you a bit better over here. So you're going to put a dowel pin here, dowel pin here. Let me make these the same. Not letting me snap there, so we'll just do it this way. All right, so you're going to put dowel pins in here, and let me just extrude those up. I'm not getting crazy with this drawing, I just want you to have an understanding. So you're going to have dowel pins in there that look something like that. Obviously you'll be able to pull them out, you know, whatever. And then you're going to take like a parallel or something like that. Oh, you'll be able to take a parallel or something, you know, whatever width you use. Let's say you used a 1-inch parallel, 6 inches long. Not going to spend the time positioning this correctly, but you'll be able to take a parallel like that. Come on. Now you'll be able to take a parallel, put it in there like that, and run an indicator across to get the clocking correctly, or get the clocking correct. You'll be able to get that part sitting correctly. Man, I got all kind of issues. But either way, I feel like you understand what I'm trying to say here. So I'm going to go ahead and delete a bunch of this junk. Okay. All right, so now we're back to our normal old model. Jump back over here. So that is how we're going to communicate from op1 to op2. Okay. So the reason we needed to, you know, go ahead and flesh that out right now is because had we not drilled those holes all the way through when we got to op2, we would not have any way to get that clocking correct. Okay. And so yeah, there we go. We drill. We drill most of the holes, drill the 2 through holes, ream most of the holes, ream the 2 through holes. Then we finish the OD, and then we finish the slot, and then we deburr it. Okay, so let me just kind of show you what that's going to look like on simulation. Go ahead and run through it pretty quick. All right, so that's what it's going to look like after after running it, and it looks like the runtime is going to be 47 minutes and 45 seconds at the posted speeds and feeds. It'll be somewhere around there, and like I've got 14 different operations, so if I was to count this, I would have 14, and I've got 9 tool changes. Okay. Now another cool thing is you've got this thing called comparison. Okay. Now, if you look, see where it's blue right there? That's showing me that there's extra material there. No, anytime you get somewhere where it's like kind of transitioning between blue and green, that's almost always a graphical issue and not really an issue with what you're doing. So let me show you more what I'm talking about. You see, if I set that tolerance to 5/10, now we're getting into the noise of the graphics on the computer. All right. So like if I set it to 10, it says, yeah, almost everything's good. If I set that to 15, yeah, everything's good. Everything is within 15 thousandths. All right. So if we set this to 5, which is, you know, reasonable tolerance, it's showing us that the OD's good, all these chamfers are good, hole diameters are good, but we've got an issue here and here, which is something that I need to address. All right, let me turn my model back on. So I'm going to pause the video, and then I'm going to pull that up to show you how we fix that, and then move on to the next topic. Okay, so I was able to fix it. I've got it turned down to, well, let me bump this back up to 5. And you see we've still got a little bit of blue, but that, again, that's just a graphical issue. That's really nothing that we should be concerned about. And all that was I wasn't giving the tool enough room to ramp on. But I would not have known that had I not done this comparison, right? You know, like if I was just looking at like this operation one, that, and all that does is changes the color based on the operation. So you see the deburn tool was blue. The through holes were yellow. The the blind holes were purple, right? So had I not done that comparison, then I would not have seen that. All right, pause one more second. All right, so we just got done talking about the comparison tool, you know, like the operation coloring and all that sort of stuff. So some of that should make a little more sense to you. Though obviously still got a lot to cover in this class. I just wanted to kind of do an overview, but not quite done yet. Let me show you the op 2. All right, so again, totally different op. So I didn't draw in like the vise and all that stuff. Sometimes I do that, sometimes I don't. But anyway, this you know, kind of shows you roughing off the top of the stock, all that sort of stuff. Let's see here. All right, so this one looks crazy because I didn't run op 1 with it. So it thinks that there's still material here. It thinks there's still material here. So this one still looks crazy. And like if I was to do the comparison on this one, you know, look at it. It's all over the place, right? But if I was to run them both, you can either shift click both of them, or you can just go up here and click simulate, and it will run through all of them. Oh, and one other thing, you never want to run graphics while you're on comparison, all right, because it just bogs the crap out of the computer. All right, so this one's running through all of them. All right, so that's a complete part. Should be, you know, if we go to comparison, should be all green. Right, and remember, you know, like I said, we still got a little bit of, you know, kind of graphical issues and stuff here, but that's not going to be an issue for us when we get out on the machines. Like you can see the graphics kind of struggling right here a little bit. Then as I move, see that? All right, so this is a good part. It's all green. Everything's within 5 thou tolerance. If I was to go to like 2.5, see, we're starting to get into that noise. But then obviously if I was to go to like 1/10, you know, now we're getting just crazy, because the computer can process these flat surfaces pretty easily, but these rounded surfaces, it struggles with those. All right, so comparison is not really a valid tool when you need to get down in like the tenths and stuff like that. But you know, for 5 thousandths, it works just fine. And also, just because this looks good on a computer, that doesn't mean that it's going to be perfect when you get out there. Your machine is going to have inaccuracies. Your tools are going to have inaccuracies. Your tool holders are going to have inaccuracies. All sorts of stuff come into play when you're talking about the accuracy of a part. The tool path is just the first part of it. All right, so there's that part. Show you this one too. I just grabbed this one out of the data panel over here. Just to kind of show you. So setup 1, let's look at setup 1 here, and I'm going to run this one. Again, turn off comparison. We'll go to operation. All right, so the first thing we're going to do, very first tool, is coming in here, cutting those. All right, so let me stop here for a second. I want you to look at this part. Go over here. Let me turn off these sketches. Oop. So look at that part. Why am I doing that? Right? And it seems kind of pointless, right? And after all, we're going to be eating up. That's showing 15 minutes. That can't be right. Maybe so. Maybe I had it dialed way back. Okay. Okay, fair enough. Surely I tweaked that when we actually ran these, but can't say for certain. So why am I spending 15 minutes cutting these? You know, when this one is going to cut all of it. All right, so let's look at it on the graphics, or on the simulation rather. All right, and the reason I did that, and if you look, it's not actually even coming into contact with that surface. See that? Not even touching it. So what's the point of all that? The point of that is for me to be able to pick up the center of that block from the second side. All right, so let me go back to the sketch here. Not so much that one. Where are we at? Maybe it is that one. So if you look, when I did this, I staged them off a certain amount. I'm not sure what that's doing. I'm not sure why that's there, but I staged them off. Like you see that triangle means that line is locked to the center. So no matter how I change this, it's going to always be the same distance off. So like, you know, what I mean by that is if I inspect from there to there, 875 thousandths. If I inspect from here to here, 875 thousandths. No matter how I change those, it's going to always stay the same. All right, I'm just going to undo all that. And the same thing here. All right, so I put those there. I just staged them off an equal amount because when I find the center, doesn't matter where I find the center of those is going to be the same. So it doesn't matter if this is 6 inches, center. Okay. And I'm just hitting Control Z to undo what I did. All right, so I needed a way to communicate op1 to op2, and that is just a kind of easy way of doing that. I can't believe that I've got that running for 15 minutes, but yeah, I did pretty slow feed rates and all that stuff, and I only went down like 50 thousandths per, so eating up a lot of time. So that was kind of the just the way we communicate that. So there's where we're roughing it, there's where we're finishing those, and then we're going through doing the rest of it. So let's simulate this. Okay. And then from there, if we go to op2, notice that notice that offset is in the center. Again, makes sense. So we're facing off a bunch of that material off the top. We're going to rough out those counter bores with, looks like a 3/16 end mill. And then we are going in finishing it with a 3/16 end mill and then deburring it with a 45-degree drill mill, well, a 90-degree drill mill, whatever you want to call it. So if we look at this all the way through, and then obviously the face mill cuts that off. So we'll look at comparison. Everything looks good. Sure why it flip-flopped that, but either way. So there's that part. And one of the things it's worth pointing out when you're designing something, I try to design out sharp corners the best I can. So had I left that corner straight, then I would have to file it. All right, and you know we want to let the machine do all the deburring for us whenever possible, and then of course go in with the drill mill and kill those corners. And when you're chamfering edges, you don't have to draw the chamfer in if you don't want to, but it's easier if you do. Okay. All right, so there's that, and I do want to show you just kind of the post-processing deal. So I'm going to highlight this one. I'm going to go in here real quick. I'm going to change this to 88888, just so that y'all see. All right, and then I just wrote comment for the program comment, and then whatever else that said. Derby, car, fixture, mark 1, op 1. Okay. All right, so then I'm going to go right here, the post process. Now, right now, hold on. Right now, all of this code is in Fusion 360 language. All right, think about it as it's in Spanish. Okay, so all this stuff makes total sense to Fusion 360 right now, but it doesn't make sense to Haas, Fadal, Akuma, any of those other machines. All right, so we need to tell it what machine we're going in. Like, are we going in, Haas turning center? Are we going in a Haas UMC 750? Are we going to be putting in a Heidenhain controller? Akuma, whatever. Okay, so these are all the post processors that we have to select from. What we use here on this campus is Haas pre-next gen control. All right, pre-NGC next gen control. It doesn't matter if you're going to be putting this on a new machine with a next gen control. All right, that post hasn't been finalized yet by Fusion, I'm guessing. And you can edit these posts whenever you can edit them, but that's a lot higher level concept, editing post. Okay, so this is where you're going to output it. I always just output it to wherever it directs me to. That's fine. Program name or number, y'all remember when I keyed in 88888 right there? Program comment, all that does is automatically populates that for us. And over here, you got some different selections. Okay, it's asking me, a handful of different options. Do I want to use optional stop? Do I want to preload the tool? The two that I primarily change the most is this. Put that on no, unless I'm on a machine that has a side mount tool changer. Okay, if you're on an umbrella style tool changer, then you don't have the ability to preload a tool. But if you're on a side mount tool changer, you can preload a tool, and it saves you a little bit of time. All right, and then over here, I always use G187. Okay, and what that does is that sets the fineness of the machine. Not so much when you're cutting straight surfaces, but when you're cutting circular objects. G187 basically puts it in a mode where it tries to hold corners really tight. All right, slows it down a little bit, but anyway, I use it. Okay, and it makes the code a little bit cleaner. All right, and then there was one other one, the sequence numbers. I do not use sequence numbers. Okay, they eat up a ton of memory, and they just make the code cloudy. Okay. No, if you like sequence numbers, use them. All right, no issues there. All right, and then all this built-in tolerance, all that stuff, that's probably not what you think it is. A lot of people think, oh, okay, I got a tight tolerance part. Let me set this to, 50 trillionths. All right, that's not going to do what you want it to do. About 2 thousandths is about where you want to put that. You know, if you need to hold some really tight circular stuff, then you can always set it a little tighter, but it's going to slow your code down. Okay. All right, so I probably got a little bit ahead of myself. I clicked post back there. Once you get all that stuff set, then you click post. All right, and if you notice, it's trying to output it as a .nc file, which is fine. This is where I always put the O in. So the letter O, not 0, the letter O. Okay, and then I simply save. What that's going to do is it's going to open up an editor for me. Should. There it is. Okay. So there is my editor. So you see that's my program name. Here's my comment, all that stuff. Oh, looks like I just screwed something up. There we go, that's better. And here's the tools that we're using, tool 2, tool 3, 4, 5, 6. All right. Here's the name of my strategy. See where I had that 2D contour 3? That's that. Okay, and if I were to change that name to something, it would be it would show up here. And there's your code. So from there, you would just go File, Save As, put it on your flash drive, and then you're done. Put it on your machine. Okay. So let me show you real quick. Let's go over here. Let me post this one. All right. So see right here where I've got my notes. See where that note is face top to net? Right there. Gyro op 1, that was my comment. So tricordial mill slot. Right there, tricordial mill slot. It just basically auto-populates all that for you. And that's a good way for you to put notes in there so that you know what's happening when you put the code on your machine. I started this out hoping it was going to be about a 20-minute video. Looks like it's turned into a 43-minute video, and I apologize. That's how it always goes with me. And anyway, so this was kind of just letting you know what all we're going to be doing in this class, what Fusion's capable of, all that sort of stuff. So the Design Academy stuff that you guys are working on right now is primarily revolved around the design side. There's a little bit of CAM information in there, but most of it is on the design side, because obviously if you can't draw the part, you can't CAM the part. All right, so you got to make sure that you get all this stuff right before we can jump over to the CAM. Now, go ahead and throw it out there. A lot of places that y'all are going to go to work, you know, you may not start out programming, you know, whatever. We're just trying to give you a fundamental understanding of what CAD CAM is all about. And then and if you do go work somewhere where you're programming, the engineering department or whatever may send you the model. You know, they may email you this model or share this model with you so that you don't have to draw it. All you have to do is the CAM. But it is extremely helpful to know what all this stuff on the design side does. All right. So that's what we're going to be up against this semester. I think it's going to be a good class. And we'll start really small. We'll start with some pretty simple projects. You know, talking about the design side, talking about why we're doing things certain ways, and then obviously we'll have some time on the machines where you will get to run your posted code. So hopefully this helps. Obviously more to come, and we'll talk to you soon.